So that works. And then we'll call this NO and MN. So we'll get MN, MO, NN, and NO. So does that work? Yeah, the child is MN. So that works. Finally,
So every time you just have a solid letter, you put O after it?
well, you could do another Punnett square that had AA, because you're not being told. We're asking, is it possible? See? And the easiest way for it to be possible is if you use AO. If it doesn't work with AO, it won't work with AA probably. You're saving yourself a Punnett square. Okay, so that's all I'm doing. And the RH, so we got RH positive, and once again we'll do heterozygous because we're not being told. RH positive, RH negative, I think we did the same one we did before. It is. It's the same one we did before up here, and the child is RH positive, and so yes, that can happen too. Okay, so that's possible. And if you do all three Punnett squares.
If you do first and second one, child.
Oh, okay, cool.
So, and we're might as well just do three Punnett squares for the bottom one.
Okay, well,
Okay, have you kind of got the drift for that?
yeah.
What I want to do is a fruit fly one. And there isn't one on here, but there is one on your lap. And so if you printed this out, Lab 6, Genetics 2, I hope you did.
And
What page? 7, yeah, 7, 8.
So I'm gonna work 2 more problems, and if that's not enough, you tell me, I'll work some more, okay? And so they got some problems. This is your big, thick honkin' lab printout. And so I'm gonna, and there's some good problems in here too. Okay. So we got 2 fruit fly ones. Let's do the number 5. In fruit fly Drosophila melanogaster, the allele for yellow body is dominant to the allele for ebony body. I'm on the last page of this lab. And so we might as well start. Okay, so I want to find one where there's an F1 generation. The genes for ebony are 7. What prior? Yeah, when a yellow body, normal eye fly with both dominant alleles on the same. So this one you're starting with the number 5. You're starting with the. Let's do number 6. Because you're on a black body made the F1 fly. Okay, because I want to take you through the whole thing. And so we're taking, and the hardest part of the whole thing is just getting the genotypes off the problem and on your paper. So we're taking a black body. So black body is the recessive one. Okay, the allele for red eyes is dominant. The allele for gray body is dominant. And so we're taking a black body And so we know it's gotta be like that. And so we're taking a black body, purple-eyed fly. And those are both the recessive, okay? They're both recessive, so they both gotta be homozygous. So that's black body, purple eye, okay? And we're crossing that with a gray body, homozygous, red eye, homozygous. So we're going gray body, okay? And this is your classical F1 cross, where you have homozygous recessive with homozygous dominant. And you'll only get one offspring out of this. And so I'll draw it over here. The F1 generation is going to be top of the left, bottom of the right. And if I do bottom of the left and top of the right, I would get the same thing. So there's only one. And so what am I going to do to this? Test cross with homozygous recessive. Okay, and so we might as well just do these. Okay, and so top of the left, bottom of the right gives me,
Homozygous recessive.
yeah, bottom of the left, top of the right. These are the two parental combinations. How do I do the recombinant combinations?
Flip the right hand
Okay,
side.
take this and flip it. So I'll draw it off to the side somewhere. And I'll keep the left the same. And flip the right. And so, top of the left. Bottom of the right. Oops, kind of a funny looking plus. And bottom of the left, top of the right. So these are the two recombinant ones. And you will be asked to write what the phenotypes are. So this is black body, purple eye, gray body, red eye, black body, red eye, gray body, purple eye. Okay? And so you're given the numbers. Ha ha ha. Anyone want to add those numbers up for me? Well, I can do it. You got to add all those numbers up.
$17.20.
1740?
20.
20? So, so 1720 divided by 69 and 71, 9 and 6 is 150. That would be 160 divided. So 160 divided by 17
140.
It's one.
was 140?
Yeah.
Oh yeah, it is 140, pardon me. So it's 140 divided by 1720. 140 divided by 1720 equals 8.1%. So these are gonna be 8.1 map units apart. And each of these, let's just call it 8%, shall we? Okay, so it'd be 4%. 4%.
Oh, there it is, 8.1.
And 46%. And 46%. See? And let's just do one more. And now we'll go to that problem sheet again. And we'll do this one. Let's do number 5, since I did number 4 there and my doodles on the back page there. Okay. And this will be the last one. Unless you guys got some more things you want me to do. There are other problems that I'd be happy to work. So in the corn plant, we got this allele for red seed is dominant over green.
Where are we at?
Number 4.
On the handout thing I gave you, the number 5.
Oh, number 5 or number 4?
Yeah. In the corn plant, the allele for red seed is dominant over green, and normal seed is dominant over tassel.
Okay.
Okay, so we're gonna get an F1 generation again. Okay, and so when a green tassel seed, so that's both recessive, and so we have S and TS. Was crossed with a red homozygous, your classical F1 cross, normal seeds, you're gonna get one F1, top of the left, bottom of the right. Okay, and so if I do bottom of the left, top of the right, I get the same thing. So what are we gonna do with this? This is our F1.
We're gonna cross it with the
Test cross it,
Yeah, with the-
okay? So what do I cross it with?
Homozygous recessive.
Homozygous recessive. And so, so this is real uptown genetics. So top of the left, bottom of the right. Bottom of the left, top of the right. Then I take our F1 and redraw it over here. Okay, top of the left, bottom of the right. I draw that right.
No, should it be S plus at the bottom?
So we had to flip. Yes, this should have an S up. No,
No.
it should have an S down here.
Yeah, at the bottom should be
Yeah.
S plus.
Yeah, it should be
Oh.
T plus at the bottom.
So keep the left hand the same,
And
flip the right side. So I did that right. So now, top of the left, bottom of the right,
Yeah.
Okay.
bottom of the left, top of the right. And once again, they give us a bunch of numbers.
So wait, what are you crossing that with again? What are the last two going across with that one and
So I took the top of the left and the bottom of the right to get that. And I took the bottom of the left and the top of the right to get that.
so why is the S plus on top?
Oh, I could have put it on the bottom and you'd be the same thing.
Okay.
You can flip them either way, and in space these things are turning over and all the time, aren't they?
Alright, that's what confused me.
So.
Bless you.
And so you add all the numbers up, and 45 and 97 is 92, and you divide 92 by the total. What is 92 by the total?
You add it all up now. And then
You add them all up, and that's the total.
You add that together and you divide by the total. 26. And then you divide that by.
And the recombinant ones
And then the
add up to
total is
92.
2% divided by 2 for the other side.
92 by the total, what is it?
26.
26%? So you'd have 26 map units apart. What are you being asked? Oh, draw a chromosome map. So if you draw a little chromosome map showing S and TS, would be here and here, and 26 map units apart. And the proportions would be 13, 13, or 26, and 26 from 100 is 74, 37, you're right, 37, 37. Now, there are other problems in the back of your lab, and I'll be glad to work any of those too. You want me to do that? Okay. Piece of cake.
Sure, it sounds good.